Hello, here is day 3 and the last video of the week. It's again statistics, and this time we're finished with measures of central tendency. Hopefully you did that 5-question CASEL learning. If not, try to get that done maybe over the weekend or in the next couple days. And now we're talking, instead of looking for the middle, which is measures of central tendency, we're going to measure the spread or the dispersion. To disperse means, to separate and kind of move them out, or variation. How do the numbers vary? Are they all bunched up? And do they start at like 90 and end at 100? Those are bunched up, not much spread there. Or does it start at 0 and go to 1,000,000? That's a lot of spread. So just like we had 4 measures of central tendency, we have 4 measures of dispersion or spread or variation, whatever number you want it, whatever word you want to use. The one you're probably most familiar with is range. It's the easiest to find, and because it's so easy to find, it really doesn't tell you a whole lot and can be very misleading. But the difference between the largest and the smallest data value. Now in your calculator it uses maximum and minimum instead. So if you wanted to, you could write that over as max minus min. Make sure it's max minus min, not min minus max. The order matters. Now it could be that you have a set of numbers that has a range of 99 and appears to be spread out, but it's not, because one number is 1 and the rest of the numbers are from 90 to 100. So if you have one unusually low number or unusually high number, it can make the range look big and look like your data is all spread out when it really isn't. Now the variance has a symbol. There's no symbol for range. Range is just range. Just like median is just median. Some things don't have symbols. But this little symbol is a sigma. And variance is sigma squared, because the definition of a variance is the mean of the squared deviations from the mean. And then I put a little formula here, and I'll come back to this once we fill out this chart, and hopefully it'll give you a better idea. The standard deviation, because when you square all these deviations, your numbers get really big. So statisticians like the variance because it's a nice show of how spread out your data is. And there's a reason we squared it, and we'll get to that in a few minutes. But when you square it, it makes each of the deviations really big. So the variance was always really, really big. And they said, okay, it's too big. So then they just took that variance and they square rooted it. So this is a sigma. This is your standard deviation. That symbol is in your calculator. But I'm going to make you do it by hand so that you can get an idea of what it really means. And most of you, if you're going off to college at some point, they usually ask you to take a statistics course. So I'm going to just give you a little intro into where the numbers come from, and if somebody asks you what the standard deviation is, maybe you know something more than that little thing, that little squiggly thing, that little OE thing in the calculator. And then there's the interquartile range. Now if your range looks really big, like maybe it's 99 because you have a 1 and 100, and the difference between 1 and 100 is 99, but almost all your grades are, between 90 and 100. So the data isn't really spread out. If your interquartile range is small, because it doesn't look at the max and the min, it looks more towards the middle of your data. So if this is really big and this is really small, that tells you that you have what's called an outlier. But if this is big and this is big, that means your data is truly all spread out. If these are both small, then your data is mushed together. And we're going to take a look at these in a couple different examples. Here's the first one. It says complete the chart. Now the variance, there's no real easy, the calculator doesn't give you variance. You can find the variance if you're given the standard deviation, obviously. If this is your standard deviation, you can square it. But the real way to find a variance is to chart it. So I have my numbers here. I put them in this calculator, and I have a different calculator today because some of you might have this calculator and the interface looks a little different. So I thought I'd use this one today instead of that yellow one. So I'm just turning it on. I've already put the data in. So there's that first set of data. Whoops, that's not. Let me get over to L1. There it is. There's that first set of data. The only difference is I put it in exactly the way it is, but if you'll notice here, I sorted it. You don't have to sort it, but it looks a little nicer sorted. And I wanted to go back and make sure that you remember that there's your sort A. And to sort A, you just tell the calculator, I want list 1 sorted. And then, it does it that quickly. Whoops, I meant to hit step. And then there's the numbers from 28 down to 50. You can't see them all because only 8 numbers or 7 numbers are there, but they're all there. If you arrow down, there they are, down to 50. Now, deviations, variance and standard deviation are both calculated using a deviation. How far? The variance is the mean or average of the squared deviations from the mean. The standard deviation is the square root of the squared deviations. So this is a very important word or statistical measure. And deviation means how far from the mean is each one of these numbers. Now the mean is in the middle, and I did the one-var stats, and I found that the mean is 39. So there's my 39, the x-bar, and I just took each of these data values you can call an x, because they're all variables. So x minus 39, 28 minus 39, 29 minus 39, 32 minus 39, and you'll notice that the ones that are below 39 all have a minus sign on them because they're below the mean. And then the ones that are above the mean have a plus sign. Now you can subtract these in your head, or you can go to the calculator and say, hey, smart calculator, here's my stat button. Whoops. Here's my list 2. And you could type in here 28 minus 39, 29 minus 39, 32 minus 39, but it's getting late. I don't want to do that. So you can also tell the calculator up here, say, hey, take all those numbers in L1, all of these, and subtract 39 from each of them. That's the mean. And there they all are. There's those numbers. Now this is a very important column. You'll notice towards the middle, towards 39, the deviations are small. As you get farther away from the mean, the deviations get big. Now because 39 was a nice number, sometimes the mean isn't nice. Sometimes, it has a few decimal places. Sometimes it is continuous and goes on forever. So these deviations now are exact. But if you have to round the mean, your deviations may be a little bit off. But this column tells you how far everything is from the mean. And the problem with that column is if I do a one-var stats with just that column 2, now this is my different calculator. You'll notice when I do one-var stats, it doesn't ask me what the data list is, what the frequency list is. So I just have to tell it, list 2. And you'll notice that it adds up to 0. That's good. That means you have not done anything wrong. You've got your data in here, you found the right mean, because the deviations are supposed to add up to 0 because the mean is the mathematical middle. And there should be just as many numbers below the mean as above the mean. So this tells us, and I'm going to put a little smiley face on this 0 because this tells us so far we're good. We haven't made any mistakes. But if every single deviation column adds up to 0, it's pretty useless because it's not going to tell us if we have a big spread or a little spread. So then the statistician said, okay, I know these deviations are really important, but we somehow have to get rid of the negative sign. So they said, hey, let's square it, because when you square numbers, they're always positive. So that's the way they got rid of the negatives and made sure that the numbers were always, that the deviations didn't always add up to 0. Now, if you recall, there's another way to get rid of those negative signs, and you could take the absolute value of these numbers. And then you could just add these numbers up. It would be much smaller than 566. Because you're squaring them, you're making these numbers huge. You could take the absolute value of them, and then it wouldn't be that big. And that is another measure of spread, which, you know, someday if you take stats, hopefully you can take a look at, but we're not. And then they said they didn't like that absolute value. They said, hey, what they liked about the squaring the deviations is it gives more weight to numbers far away from the mean, and really told you if you had a big spread or a small spread. So if your numbers are close to the mean, this number, I squared it, didn't even change. This number just doubled. But as you get farther away from the mean, this one quadrupled. And then these numbers got big. So that's why they liked squaring it, because squaring the deviations gives more weight to those numbers far away from the mean. Now, if you add those numbers up, because I have to find a mean, and the first job in finding a mean is to add these up. So I just take stats, calculate, I am in L. Oh, I don't even have these numbers in my calculator yet. So I got to go back here. Here are these numbers. I'm going to go over here. I've got to square them. So now I'm going to tell the calculator, take out 2, square those numbers. And there's all those big numbers. And now I'm going to tell it to take one var stats. I got too many one var stats there. One var stats. Make sure you only have one var stats. If there's anything else in this line, if there's like, if it's 2 plus one var stats or 3 times one var stats, it's not going to work. So now I'm pretty sure that was L3. And there's that. I want to know what it adds up to, because when I find a mean, I add it up, and then we do eventually divide it by 10, because there's 10 numbers, and there is the mean, 56.6, the mean of the squared deviations. That's my variance. Then you square root it, and you get the variance, or the standard deviations. So I took the square root of 56.6, and I got this number. Now, when I did that, I wrote the whole number down. I know you can round it, but I didn't round it for a reason. And we're just going to, if they ask you to if they don't tell you what to round to, although in the vast majority of the cases they should, you just round to, usually, just like yesterday, 1 place past raw data, or 1 decimal place. So this standard deviation appears to be 7.5. See that number? Now this is what my students, my stat students especially, because I didn't get to do this with my Algebra 2 this year, is if you go back, look at that number, and I'm going to put the calculator here. If you go back and do the stat with that original first set of data that we had, hello, where am I? Oh, I'm on enter. L1, I don't have to put L1, you'll see that same number as that sigma. I just wanted you to know where it came from, that it isn't just this thing in the calculator. You need to know, and had you taken the Regents exam, they may have asked you something about deviations and, you know, what the formula was, and you may need to know more about standard deviation besides the fact that it's that little symbol in your calculator. And then finally, IQR. I kind of found the quartiles. We didn't talk much about the quartiles, but 39 is right here. Here's your mean, or your, I guess you should say the median. The median is going to be halfway between 38 and 41. so that there's 5 grades below, 5 grades above. In between here someplace is your median. And then below the median, there's 1, 2, 3, 4, 5 grades. The median of the numbers below the median is the first quartile. Sometimes they call that the lower quartile. The median of the grades above the quartile are the third quartile. And then I just subtracted those two numbers. And then as you look at those, 22 is your range, 15 is your interquartile range. This should be smaller than this, but it's not that much smaller, which tells us that our data is pretty close together. And then the standard deviation is fairly small. That means your data definitely looks pretty bunched up here. Now here's the last page. Now here we're just going to do it just using the calculator. I put the numbers in here. You don't, I'm pretty sure. Let me see, stat. I just put them in a different list. Here they are. So I have them in list 4. There's the numbers. You don't have to do that whole chart. I just wanted to give you an idea of what those numbers meant instead of just, you know, this is how I find them. So here are the numbers that I put in the calculator. They're in list 4. So I'm just going to go stat, calculate, enter. I'm going to tell the calculator, I think I said all 4, so I'm going to say second 4. And there is, now I'm going to try to find my range. I'm going to go down here. My range is going to be 60 minus 21. So there's 60 minus 21, there's my 39. Interquartile range, there's my Q3 minus Q1. Whoops, Q1 is 24. So that's 54 minus 24, that's 30. They're kind of close together. The variance the calculator doesn't give me, but I'm going to go back up here. There's my standard deviation, 3.8. Now this is important. 13.8, that is rounded. When you take that number and square it, you should write out the whole number. I typed out that whole thing and squared it. And this is the closest I can get. This is the variance to the nearest tenth. This is the standard deviation to the nearest tenth. But if you don't want to type all those numbers in and you say, hey, I'm taking the shortcut, 13.8 squared is not going to give you 191.2. Because you hacked off all those numbers, it did not give you an accurate answer. So be careful. Don't round and square. We want you to square and then round to be most accurate. Okay, finally, we're going to put everything together. We have our 4 measures of central tendency. We have our 4 measures of variance. And then we're going to check to make sure that I did these correctly. So I'm going back to stats. And here is, I had to remind myself here, these are my last couple lists here. So I have list 5 and 6. Because I'm using a frequency list, please make sure you have the same number. You can't have more scores than frequencies or more frequencies than scores. So I put all those numbers in. They're in L5 and L6, and this is a different calculator. It has a different interface. So here you're going to have to say L5, comma, right above the 7, L6. And there is my mean. I didn't say this, but I'm just rounding to the nearest tenth. I should have given that direction there. Then I'm going to go, I look up here, 12. There's my mode. I'm coming over here. My median is 80. Whoops, where's my median? There it is. There's my median is 90. My mid-range is 100. Whoops, I did that wrong. 100 minus 75. I changed it over here. I didn't go down far enough, so this is going to be 100. Where the range is maximum minus minimum. The mid-range is maximum plus minimum. So that's going to be 175 divided by 2. Because sometimes I think when I was looking at it, this was cut off and I didn't look close enough. So just try to be careful. So that's 175 divided by 2. And there's my 87.5. Pretty close. Remember, 87.5. Remember, these are supposed to be measures of central tendency. Remember, I don't like the mode. The mode really doesn't tell me much because they're down here. But your 3 measures of central tendency are pretty close together. I like that. I'm going to put this up here again so you can see it. 87.5. And then we go to our measures of dispersion. Range is 100 minus 75. Interquartile range, there's that 95. Interquartile range is the 95 minus 80. Quartile 3 minus quartile 1. Now here's my range 25, 15. Those are pretty close together, meaning your data values don't vary that much. They start at 75 and they go to 100. The standard deviation, and here's one last thing. Please remember with rounding, where'd it go? This, oh, I can't go back up again. I gotta go and do this again. That was, what was that? It was L5, L6, comma, L6. Now, there's my standard deviation. If they tell you to round to the nearest tenth, there it is, 7.96 to the nearest tenth is 8.0. You must put that 0 there. If you don't put the 0 there and you just put 8, you haven't rounded it to the nearest tenth, and they think you didn't follow directions or you don't know where the tenths place is. So even if it's 0, put that tenths place in. And then I took that big long number, 7.96, and you'll notice that 8 squared is 64, and this is a little bit lower. But please make sure that you put that whole number in, or put at least 4 decimal places in so that you get an accurate number. Okay, there is your measures of dispersion, and that's what we call descriptive statistics. Measures of central tendency, measures of dispersion. Now tomorrow I won't have a video. I'm just going to post, tomorrow morning there'll be a Google form, and I'll have 10 questions in it asking you to find mean, medians, modes, ranges, all of those things. So it's been a pleasure presenting you this information this week. Enjoy. It's been really hot, but it's supposed to cool off tomorrow. Take care. Enjoy. Check eSchool and email your teacher if there is a grade there that it says you haven't handed it in yet and you have submitted it or you have done it. Okay, take care. Bye.